Hello students, I am Pushkar, Master Teacher in Chemistry at Vedantu. I am discussing few interesting questions in JEE Advanced 2020 Chemistry. Let's discuss problem number 17. The problem is of numeric type. In this problem, 23892 uranium is known to undergo radioactive decay to form 20682 lead by emitting alpha and beta particle. A rock initially contained 68 into 10 to the power minus 6 grams of 23892 uranium. If the number of alpha particles that it would emit during its radioactive decay in 3 half-lives Z into 10 to the power 18, then what is the value of Z? So, how to solve this problem? Let's see a few steps. First, let's collect what to do in this problem. First of all, you must calculate that 23892 uranium, when it changes to 20682 lead, how many alpha particles it will emit. First thing, we'll calculate that. To calculate that, we'll have to find the difference in mass number, and as you can see, 238 minus 206, that is the difference in mass, is equals to 232. That means 32 units. Now, the mass of one alpha particle is mass of one alpha particle is equal to 4 unit. So this gives us that 8 alpha particle. So which means that 23892 uranium will emit 8 alpha particle while it is converting it to 20682 lead. We got this information. Next, how many moles of uranium is there? So to find out the moles of this is 68 upon 238 into 10 to the power minus 6. As you can see here, this is number of mole of uranium, 238. And if we convert it into numbers, because in radioactivity we need numbers, then we'll have 68 upon 238 into 10 to the power minus 6 into 6.023 into 10 to the power 23. Let's call this number as to be a naught. This is the number of uranium atoms which was initially present. Now comes the kinetics part. In 3 half-lives, that 23892 uranium is decaying, in 3 half-lives, as we very well know, that if N0 was the initial number of atoms, in one half-life, it will be N0 by 2. In another half-life, it will be N0 by 4. And in another half-life, it will be N0 by 8. So that will be the final number of moles after 3 half-lives. So that gives us how many has decayed. So number decayed is equal to N0 minus N0 by 8, which is 7 by 8 N0. So this many uranium has decayed, and in every decay that's going to give you what? 8 alpha particles. So that means number of alpha particles is emitted is equal to 7 by 8 into N0 into 8. That comes out to be 7 N0. Now let us substitute the value of N0 here. 7 into, as you can see, the value of N0 was 68 upon 238 into 10 to the power minus 6 into 6.023 into 10 to the power 23. So upon solving, you can see the clear factors here, 34, 119, this is 17 and this is 2. So you're going to get 2 into 6.023 into 10 to the power 17, and which is 12.046 into 10 to the power 17, and you can represent it 1.2046 into 10 to the power 18. So it was a bit calculative question, little bit of concept was used here, very ordinary problem, and there's nothing special about this problem. Thanks for watching. For detailed discussions of other problems, stay tuned. Thank you.